Hello and welcome to a discussion about some of the applications of trig functions. At this point we've been talking about some of the trig functions, well, all of the trig functions, and we want to see where math gets relevant, right? When math gets real. There are a few things treated in this sequence of videos, just ways that we might use those trig functions in real life. So this video is going to focus on how do you solve a right triangle? So what does it mean to solve a right triangle? Well, all that really means is to identify all the side lengths and all the angle measures in that triangle. So when we are asked to solve a right triangle, we're going to be given some information. And based on what information has been given to us, it will require one or more than one tool. So what are the tools most appropriate for solving right triangles? Well, one of the tools, if you know one of the acute angles in a right triangle, you can use the triangle sum theorem to find the other acute angle measure. And you probably know this, but you may not know the name. The triangle sum theorem just says that the sum of the measures of the interior angles in any triangle will add up to be 180 degrees. So if you know one of the acute angles and you know the right angle, then you can find that third angle. And it doesn't have to be in that order, but just if you know two out of the three, you can find the third. Another tool, if you know two of the side lengths, you can use the Pythagorean theorem to find the remaining side length. So depending on what sides you know, you would just set it up so that a squared plus b squared would equal c squared, where c is your hypotenuse. And A and B are the legs of that right triangle. Okay, another tool that you might use, if you happen to know a side length and an acute angle measure, you can use what you know about right triangle trig. And that's commonly known as SOHCAHTOA, right? The sine of an angle is the ratio of the opposite side over the hypotenuse. And the cosine of an angle is the ratio of the adjacent side over the hypotenuse. And the tangent of an angle is the ratio of the opposite side to the adjacent side. So depending on what you know, if you know a side length and an acute angle measure, that would be appropriate. And then lastly, if you just know the side lengths, and you need to find the angle measures, you're going to use the inverse trig functions with right triangle trig to find those angle measures. So let's try a couple of examples. All right, so here's an example of a triangle. And notice that we are given that the measure of angle A is 51 degrees and the side length, oh, what is the side length? Ooh, do you know? Okay, this side length is 9 inches, but remember that it is convention for us to name the opposite side to an angle with the same letter but in lowercase. So this is going to be side A, and this will be side B, and this will be side C. So it makes sense to go ahead and organize our work. Write down what we know, and that is going to help us determine strategy and what we need. Okay, so we know measure of angle A is 51 degrees, and we know measure of angle C is 90 degrees, and we know the length of side A is 9 inches. So let's go ahead and fill those in. Okay, and so when I'm looking at this like it is, then it makes sense for me to say, oh, well, I know two of my angles. Let's find the third one. Okay, and we would go ahead and use our triangle sum theorem there and sub in everything that we know and solve for angle B, which would be 39 degrees. Okay, so now I've got all my angles, and now I want to find my side. If I know one of the side lengths and any of the acute angles, then I can use my right triangle trig. Okay, so let's look at, I have angle A, which is 51 degrees. So let's focus on the sine of angle A, which will be side A over side C, right? Opposite over hypotenuse. And let's fill in what we know there. The sine of angle A is the same as the sine of 51 degrees. And little a is 9 inches. So now I've got this nice trig equation, and I can solve for C. by multiplying both sides by c and dividing by the sine of 51 degrees. So c is equal to 9 inches divided by the sine of 51 degrees. And then I would crunch this in my calculator and get c is 11.6 inches. So let's go ahead and fill that in. All right, so I'm going to use right triangle trig for the other side measure too, and I'll show you why. Okay. So let's look at that measure of angle A again, and let's this time use tangent of angle A. So to get B, I can use a tangent because the tangent of angle A will be opposite over adjacent, or A over B. Filling those things in, we have the tangent of 51 degrees is equal to 9 over B, and B would equal 9 over the tangent of 51 degrees, which is 7.3. So 7.3 inches. All right, so now I've got my side lengths and my angle measures, and it's always kind of a nice idea for us to check our work, and that's why I did not use Pythagorean theorem to get the third side length. So now I can check it using the Pythagorean theorem. Putting in the legs of that triangle, 9 squared plus 7.3 squared, is that equal to 11.6 squared? Well, when I crunch those numbers, it's darn close. This ends up being 134.29, and this is 134.56, and that's just because we rounded a little bit. So we can say that that does work out, and we can be very confident that we have solved this triangle correctly. Right, let's look at another example of solving right triangles. Here's another one. All right, this time I don't have any angle measures. All I have are two side lengths. So let's start with how we did this before. Let's label each of the sides. Let's organize our work. And so we can say that the side to the right is side B, the side to the bottom is side A, and the side that is the hypotenuse is side C. So filling in everything we know one angle measure just because it's a right triangle, and then we know two of the side lengths. So it makes sense to start where I have more information and I have two side lengths, which means I'm going to solve for the third one by using the Pythagorean theorem. Okay, so if I set that up, I know that C is my hypotenuse, which means it must be in that C spot, C squared. And then one of my legs, and you could have put that either here or here, but since we've got these labeled as A and B, it made sense to put it here. So 4 squared plus B squared is equal to 5 squared, which means B squared is equal to 9. And so B would have to equal 3 centimeters. Okay, so let's go ahead and put that there. All right, so now I've got all three sides, and I'm interested in an angle measure. So let's think about how could I relate the two sides that I'm given to either angle B or angle A? Well, we're going to have to use an inverse trig function for sure. Let's focus on angle B first. If I'm thinking about angle B, the cosine of angle B will be 4 over 5, or adjacent over hypotenuse. Okay, and so now if I want to isolate B, I'm going to have to take an inverse trig function of cosine, or the cosine inverse of both sides. And so B will equal the cosine inverse of 4/5, which we can get from our calculator, and we ended up with B is about 36.9 degrees. All right, and then we would do the same thing for angle A, except for angle A, we're going to go opposite over hypotenuse, which will be our sine function. So we would say the sine of angle A is A over C, which means the sine of angle A is 4/5, which means A will equal the sine inverse of 4/5. And then we can crunch that in our calculator and find that the measure of angle A is 53.1 degrees. Now, this is where I can use the triangle sum theorem to check, because now I have my three angles. I want to add them up and verify that they equal 180 degrees, and yes, they do. So I am very confident that I have solved that right triangle correctly as well. Stay tuned for more applications of trig functions in the next video. I'll see you then.